school math analyzers. Today's video is about translations of functions. Did you miss our previous videos? This summer, high school math analyzers are presenting a 4-part series on functions. Click on the card on the top right corner to check out the playlist. Here's a cheat sheet to help you. On the left side, we have transformation of f of x, and on the right side, we have transformation of graph of f of x. The first one we have is f open parentheses x plus h close parentheses, which means translating h units left. The next one we have is f open parentheses x minus h close parentheses, which means translating h units right. The next one we have is f open parentheses x close parentheses plus k, which means translating k units up. And we have f open parentheses x close parentheses minus k, which means translating k units down. So keep this in mind throughout the video. Let's talk about horizontal shift, which means moving left or right. Translate each unit left. The transformation of f of x will be f open parentheses x plus h close parentheses. I've shown 2 examples here and we will go over them. In the first graph, we have f of x equals x squared and f open parentheses x plus 2 close parentheses. Since there's a plus 2 here, that means that we are translating the function 2 units left. Let me try to prove that to you on the graph. Our origin here is right here at 0, 0. And we can see if we move 2 units to the left, we get to negative 2, 0. So that shows how we translate h units left. Let's look at the second graph. We have f of x equals 2x cubed, and we have f open parentheses x plus 1 close parentheses. Since there's a plus 1 here, that means we're moving 1 unit left. Let's look at the origin for our f of x, which is at 0, 0. We move 1 unit to the left, and we get to negative 1, 0. So that shows translating 1 unit to the left. Translate h units right. The transformation of f of x is f open parentheses x minus h close parentheses. Again, we have 2 graphs here, so let's get started. The first graph we have is f of x equals x to the 4th power, and we have f open parentheses x minus 1 close parentheses. This minus 1 tells us that we're moving 1 unit to the right. So let's try to test that. Our origin is at 0, 0, and if we move 1 unit right, we're at 1, 0. So it shows translating 1 unit right. Let's look at the second graph. We have f of x equals x and f open parentheses x minus 3 close parentheses. This means that we're moving 3 units to the right. So let's look at the origin. Our origin is at 0, 0, and we're moving to the right 3 units. So if I move to the right 3 units, get to here, which is 3, 0, showing that we're translating 3 units right. Now let's talk about vertical shift, which means moving up or down. Translate k units up. The transformation of f of x is f of x plus k. On our first graph, we have f of x equals 3x cubed, and we have f of x plus 2. Now this plus 2 means moving 2 units up. So let's look at the origin of our original function, which is at 0, 0. If we move up 2 units up, we get the coordinate of 0, 2. So it shows translating 2 units up. Let's look at the second graph. The second graph we have x to the ninth power, and we have f of x plus 1. This f of x plus 1 means 1 unit up. Alright, so let's look at the original function's origin, which is at 0, 0. Move 1 unit up, and we get to the point 0, 1. So that shows translating 1 unit up. Translate k units down. The transformation of f of x is f of x minus k. On our first graph, we have f of x equals 5x to the fifth power, and f of x minus 4. So this minus 4 represents moving 4 units down. So let's look at the origin of our original function, which is at 0, 0. And if we move 4 units down, we get to 0, negative 4. So that shows translating 4 units down on a graph. Now let's look at the second graph. We have f of x equals 5x squared, and we have f of x minus 4. This minus 4, again, represents moving the function 4 units down. Let's look at the origin, 0, 0, and 4 units down gets us to 0, negative 4. So that shows, again, translating 4 units down. Now let's try out some regions problems. Remember to pause the video before going over the problems. You got this. Which transformation of y equals f of x moves the graph 7 units to the left and 3 units down? Remember to pause the video before I explain the answer. Okay, so in order to solve this, you must recognize that there are two transformations that we need to do, which is 7 units to the left and 3 units down. Let's start with translating to the left. This means y equals f of x plus h. H is the units we are moving to the left. So y equals f of x plus, plug in the units we're moving left, which is 7. Now we can do translating down. The equation for that is y equals f of x plus 7 minus k. K represents the units we're moving down. So we can plug that in, and we get our answer as y equals f of x plus 7 minus 3, which is why our answer choice is answer choice 1. The minimum point on a graph of the equation y equals f of x is -1, -3. What is the minimum point on the graph of the equation y equals f of x plus 5? Remember to pause the video before I explain the answer. In order to solve this, we must ask the question, what is the transformation of f of x? Looking at the new equation, we have y equals f of x plus 5. Now that is in the form of translating k units up. This means that the function is moving 5 units up. So our minimum point of f of x is -1, -3. This means that we will add 5 units to the y coordinate, which gets us the coordinate of -1, 2, which is why our answer is answer choice 1. The maximum point on the graph of the equation y equals f of x is 2, -3. What is the maximum point on the graph of the equation y equals f of x minus 4? Remember to pause the video before I explain the answer. In order to solve this, we must ask what is the transformation here. So the new equation that we had is y equals f of x minus 4. This means that we're translating 4 units right. So we can write translate 4 units right. Our maximum point on the original function was 2, -3. This means that we're adding 4 to our x-coordinate, getting us the answer of 6, comma, -3, which is why our answer is answer choice 4. The graph below shows the function f of x. Which graph represents the function f of x plus 2? Remember to pause the video before I share my answer. Okay, so in order to solve this, we must recognize that this f of x plus 2 is in the form f of x plus h, which just means translate h units left. So that means that if we plug that in, we're translating 2 units left. So let's do this on the graph. I'm picking a point at the origin, which is at 0, 0. If we translate 2 units left, should be somewhere around here, which is -2, 0. And on a graph that has origin at -2, 0 is graph number 2. That is why our answer choice is answer choice 2. The graph of y equals f of x is shown below. What is the graph of y equals f of x plus 1 minus 2? Remember to pause the video before I share the answer. In order to solve this, we must recognize that there are 2 transformations. One is translating 1 unit left, as we can see from here. Another is translate 2 units down. So in order to figure out which graph is correct, let's pick a point. I'm going to pick -2, 1. So translate 1 unit left. Now we move 2 units down, and we get the point -3, -1. The only graph with that coordinate is answer choice 1 right here, and that's why our answer choice is 1. Please subscribe, hit the like button, comment, and share this video. Follow us on Instagram and Twitter at High School Math Analyzers. Thanks for watching. We hope you learned something new, and we'll see you in the next one.